Well, hello everyone. This video is primarily for a class I'm teaching, a scripting projects class, and so I assume most of the folks watching this will be my students in that class. Hello, student in my class. But if you happen to stumble across this and watch it sort of out of context, it might be useful nevertheless. But this is really the intro to a project we're doing in my scripting class. All right. So having said that. Why are we talking about reverse Polish notation calculators, and what are they? So if you've seen this video before you read our assignment, in a nutshell, we will use our Python knowledge to build a little calculator in a Python script. And we're not going to use just any calculator. We are going to implement a classic version of a handheld calculator using something called reverse Polish notation. And so let's figure out what that is. Now, I'm not generally a huge fan of Wikipedia, but if you sort of have an idea of what you're looking for and you just want to get the details, it's actually not half bad. So here's the article, and I've linked it off our webpage as well. Here's the article in Wikipedia on reverse Polish notation. And I'm not going to scroll through this or anything, but I just want to show you that that's kind of gives you kind of a basic outline on what this is. And I'll show you a demonstration. It's much easier than trying to read through this and figure out how this works. So a couple of notes. First of all, there's absolutely no reason why we should write a calculator on Python, other than as a fun project. Because obviously there's like thousands of calculators out there, and even more so, why a reverse Polish notation calculator? I mean, we have Excel and everything else, but it's kind of a historical fun thing to play around with, and it gets us to exercise a lot of things we've been trying to learn in Python. So when calculators first came out, and there's a fun website. It's called the Museum of HP Calculators, and HP is, I think, the only company that I know that actually implemented this weird way of using calculators. HP started this doing it about 1968. So that would make it, what, I don't know, my math fails me, over 50 years ago. And to give you an idea, if you haven't seen these, I'm trying to find the one. I think this is the one I had for the longest time. Nice, fits in your shirt pocket like a slide rule. Yeah, I was a geek then. I'm probably a geek now. Anyway, this was a classic HP calculator, and most calculators of the time had, the advanced ones at least, had a way to put in parentheses, so you could do the same kinds of equations that you're used to typing into Excel. And they did equal sign, so you typed a bunch of stuff and you hit equal and it does the calculation. If you use a calculator today, of course, you know all that. Notice that this one has neither parentheses nor does it have an equal sign, but it has this weird thing called an enter key. And that, if you see that, this is a reverse Polish notation calculator. And the whole point of that weird scheme had to do with calculators, because I don't think anybody's ever done a scientific study, but there was some sense that with calculators, Excel is a whole different story. We've got a full keyboard you're working with, but with these funky handheld devices where you're going like that, and we were really not very good at that because we didn't have cell phones, so nobody had practice doing that. We also didn't have game consoles that trained your thumbs that way. Typing in and sort of from memory and typing in equations with parentheses, multiple levels of which and whatever, and getting that right. And if you make a mistake, you get a backspace and edit or delete. Some of them didn't have an edit mode. So, some time ago, and you can read the Wikipedia article, somebody come up with a different way of writing calculations. what we the way we write arithmetic, what we learned it from grade school, is we write 1 plus 2. Polish notation has the operation first, so it would be plus 1, 2. So it says I want to add number 1 and number 2. Reverse Polish notation, which these calculators use, does the other way. It says 1, 2, plus. In other words, we put in a 1, we put in a 2, and then we tell the calculator to add those two numbers. It turns out there's a learning curve to it, but once you know how to use an RPN calculator, reverse Polish notation calculator, you can actually be really fast, even when you're doing relatively complicated calculations. And so, like I said, why would we do? There's no practical reason for doing this today, but it's fun and it's different. All right, so I can talk about this all day long, but it probably doesn't make any sense whatsoever. Now, I tried a couple of different apps, and I wasn't particularly happy with what I found. But then I came across actually a website, and I've linked this from our webpage as well. This is apparently a site that has a whole bunch of different emulates a whole bunch of different calculators, including an RPN calculator. So. And I'm since you can't see my keyboard, I'm going to click numbers here on the screen so you can see what I'm doing. But understand that clicking a number or typing a number would be the same thing, and enter is the same thing as the enter key on your keyboard. So we said to add 1 plus 2, I would do 1, enter, 2, plus, and the result 3 would show up in here. These 4 locations are called the stack, and they've had various there's various nomenclatures. For us, we will implement these things as a Python list. So think of these as index 0, 1, 2, and 3. I think in the calculators are often called X, Y, Z, and T, I think, for top, or temporary, whatever it may be. So if you had to do something a little bit more complicated, let's say we want to do 5 plus 7 over 2. Let me clear this. I could do 5, enter, 7 plus 2, divide. Whoops, I hit the percent instead. Let me do this again. So 7, enter, 5, plus 2, divide. Right, and so no parentheses, no equal sign, and again, if you know how to use these, you can actually be pretty quick with them. Our project we want to implement something like this. So the first thing we to do, and this is going to be your intermediate set of projects. The first thing we'd have to do is implement the stack, and then as the final, then once we do the stack, then we have to go through and implement the some arithmetic functions. We're going to stick pretty much with the ones you see here. I don't know if you're going to do you'll see in the assignment. I think what we're going to do is we'll do the 4 basic operations: plus, minus, multiply, and divide. We'll do a 1 over, so you can invert. X is always the lowest, the 0 entry here. And I'll show you a couple of things here. So we'll probably do x, 1 over x. We do a power and the square root. We'll have to implement a couple of convenience functions like clearing the stack, for example. So a few of these, as I said, you'll do it initially, and then you have to add a few more. So a couple of things. So when I enter a number, it gets automatically entered into the bottom position of the stack. So that will be our user typing in a number and entering it. If I have something in the bottom position already, and I hit enter without having typed in another number, so our user would just hit enter on an empty line, whatever was in the lowest position, 0 position, gets pushed up to the 1 position. Let's put a 2 here. All right, so we can keep pushing. Oops, I did that wrong. So I do 1, enter, 2, enter, 3, enter, 4. And so every time I make a new entry, it pushes the the numbers up in the stack. If I try to put more, oops, go back. There. So if I push another, if I push more than, if I keep doing this, eventually I push things off the top. Let's do this. So if I didn't enter one of those. Okay, so so I can have up to 4 numbers here. Sometimes I want to drop the stack down, delete what's in the entry position, and that's called popping an entry off the stack. That brings it down. That gets rid of the lowest one, brings it down, and puts the well, I put the second entry into the first, the third entry the second, and the fourth entry the third. Out of curiosity, so if I put something back in, it pushes it back up. So we need to implement this idea that the stack can go up and down. So I can pop these down, and ultimately I end up with an empty stack. Another thing I can do is I can do 1, I can enter a 2, and I can swap the. You can only swap the lowest 2. Right, so I can reverse. I can play with the lowest 2 entries and swap them back and forth, and that comes in handy sometimes. Any function we implement, something like a square root. So let's put something in here that's actually useful. Let me swap it back. So so if I implement a square root, it always acts on the lowest entry. So if I have a function like square root, always ends on the lowest entry. Things that require two operands are always operate on the lower 2, right? So let's do a 5 and a 10. All right, if I add those 2 together. If I subtract the lowest from the one above it. So in a way, this looks a lot like long addition or long subtraction that you might have learned in school. Let's do 5, enter, put in a 10. If I divide, I'm dividing just like with long division. I'm dividing the second entry by the first. So the one above gets divided by the one below. So it's logical. And obviously, you multiply the bottom 2. I always get confused. So power means raising a number to the power of another, and I think it works the same way. But I need to make sure this guy actually. I didn't try it and see if this thing actually implements this properly. So I think if we hit power here, we should get 10 squared, but I am not sure. Not sure about that. Yeah. So it takes the second number and raises it to the power of the first. And so if we do it the other way around, 2 first, then 10, we should get 1024, which is 2 to the power 10. All right, that's that is the gist of a reverse Polish notation calculator. And you'll see in the assignment, the first thing we'll do is to implement the idea that every time our user enters something, it goes. I didn't hit the enter here. Every time the user enters a number, it goes on the stack, and if we enter another number, it pushes the stack up, and then we'll want to implement the idea of popping numbers down the stack as well. So those will be the first thing we'll do. We might add the swap as well, and of course we have to be able to display this stack each time. All right. That's what I wanted to do here. Hope this should be a good introduction to what you're supposed to do and what your calculator is supposed to do. And of course, we're going to talk about this in class as well. So I will see you in class.